Hi everyone! Today we'll be discussing two common arc welding processes, gas metal arc welding GMAW and gas tungsten arc welding GTAW. We will describe and compare the processes, analyze their advantages and disadvantages, and discuss common welding defects and distortion. 1. I can discuss about GMAW and GTAW process. I can explain the method of welding. GMAW, the process, use a continuous solid wire electrode feed through a welding gun and a shielding gas to protect the weld from contamination. GTAW, this process uses a non-consumable tungsten electrode to create the arc and a spiral filler metal is added manually. A shielding gas is also used. Secondly, I can discuss the welding machine. Both processes use a power source, but the setup differ. GMAW machine have a wire feeder, while GTAW machine typically have a foot pedal for current control. Before that, I can describe the shielding gas and identify the electrode for GMAW and GTAW. The electrode GMAW use a consumable wire electrode that also acts as the filler metal, but GTAW use a non-consumable tungsten electrode.
The types of current and polarity is gas metal arc welding, gas tungsten arc weldings. Gas metal arc weldings is process usually use direct current electrode positive. It's called DCEP. DCEP provides a stable arc and good penetrations, which is ideal for strong welds. Gas tungsten arc weldings can use direct currents electrode negative DCEN from most metals or alternating current, it's called AC, for materials like aluminium, magnesium, where surface cleaning is needed. The effects of the polarity is direct current electrode positive, direct current electrode negative, and alternating current. Direct current electrode positive gives deep penetrations and creates a narrow bed, which is great for thicker materials. Direct current electrode negative results in shallow penetrations and a wider bed, making it better for thin materials. Alternating current, this provides a cleaning action on the surface of the workpiece, which is very useful when welding materials like aluminium. So, in summary, the type of current and polarity we choose depends on the materials we were welding and the kind of results we want, whether that's deep penetrations, a clip surface, or a wide bed.
I'm Asrul. I will be presenting step 3, the advantage and disadvantage of gas metal and gas tungsten arc welding methods. So first we have gas metal arc welding. Gas metal arc welding offer a high deposition rate, which means more weld metal is added in less time. It also allows fast welding speeds, making it efficiently for large projects. And also, it's relatively easy to learn, so it's suitable for beginners and production work. But gas metal gives less control over the weld pool, which can affect the weld quality. So it can also produce more spatter, leading to extra cleaning and finishing work. And it's not suitable for all welding positions unless specific techniques are applied. While gas tungsten arc welding methods, it provides precise control over the welding process, producing high quality welds. It can also be used on a wide range of materials including thin metals and non-ferrous alloy. However, gas tungsten arc welding is a slower process compared to gas metal, and also it requires a higher skill level to master, and it has a lower deposition rate, so it's not as fast for thick materials. In conclusion, gas metal is faster and easier to use, while gas tungsten arc welding provides more precision and cleaning results. But both can be used depending on your project requirement. That's all for me.
Hi everyone, welcome to part of my presentation, which is common welding defect and prevention. Today we'll be focusing on step 4, which is part 2 of our series on welding defect and distortion. Let's start by identifying common welding defect. These include porosity, which are gas bubbles trapped in the weld; slag inclusion, which are non-metallic solid; lack of fusion, where the weld doesn't properly bond with the base metal; cracks, which can weaken the weld and undercut a groove melted into the base metal next to the weld. Now, let's discuss prevention methods. First, always properly clean the base metal to remove any contaminants. Use the correct shielding gas flow rate to protect the weld from atmospheric gas. Ensure proper welding parameters, include current, voltage, and traverse speed, are set correctly. Lastly, use the correct electrode and fillet metal for the specific materials you are welding. That's all for me. Thank you.
Hi. So I'm going to talk about welding distortion or occurs. So first, welding distortion occurs when a metal expands during heating and then contracts as it cools down. Because this heating and cooling do not happen evenly, the metal parts may bend, twist, or change shape. This problem is very common in welding, especially when working with thin materials or when heat is applied unevenly. There are several types of distortion that can occur during welding. The first one is angle distortion, which happens when one side of the weld shrinks more than the other side, causing the welded joint to be bent at an angle. The second is transverse shrinkage, where the metal contracts across the width of the weld joint, reducing to overall width. The third type of longitudinal shrinkage, which occurs along the length of the weld and can pull the material inward or shorten the piece. Lastly, there is bowing or buckling, which happens when the entire welded part curves or wraps due to uneven heat or restraint during welding. To minimize distortion, welders can use several effective methods. First, is it important to use proper clamping and fixturing to hold the weld piece firmly in place during welding so they can move or deform. Second, apply a balanced welding sequence such as backstab welding or symmetrical welding to ensure the heat is distributed evenly on both sides. Third, preheating and post-heating techniques can be used to reduce the temperature difference between the weld area and the base metal, which helps minimize thermal stress. Next, control the welding parameters, such as current, voltage, and traverse speed, to avoid excessive heat input that can cause distortion. And finally, try to use the minimum amount of filter metal needed for the weld, since more filter metals means more heat and higher chance of distortion. That's it from me. Thank you.
Now, let me close our presentation. In conclusion, GMAW and GTAW are both valuable arc welding process with distinct characteristics. Understanding their maintenance, advantages, disadvantages, and how prevent defects and distortion is crucial for producing high quality rates. That's all from us. Thank you.